Good evening, this is Indranil Verma. Today we will be studying about the second section of basic maths, that is binomial theorem. Binomial theorem. It is used to expand the expressions. We have a mathematical expression up to power of something. Then we use the binomial theorem to expand that expression into a certain solution. Let me show you an example. Let us take an example like 1 plus x to the power n. Now we will expand this equation according to the binomial theorem. According to binomial theorem, 1 plus nx plus n into n minus 1 upon 2 factorial plus n into n minus 1 into n minus 2 upon 3 factorial plus so on. Now here 1 plus x to the power n is equal to 1 plus nx plus n into n minus 1 upon 2 factorial plus n into n minus 1 n minus 2 upon 3 factorial, and this so on, n minus 1 n minus 2. Here will be n minus 1 into n minus 2 into n minus 3 upon 4 factorial. It will continue into the series. Now the confusion may arise that what is this factorial? 2 factorial, 3 factorial. So stating about these, 2 and inverse exclamatory sign. Exclamatory sign is like this, and I am just doing the inverse of this. 2 inverse exclamatory sign. We used to read it as 2 factorial. 2 factorial means 1 into 2 is equal to 2. Similarly, 3 factorial is equal to 1 into 2 into 3 is equal to 6. Similarly, 4 factorial is equal to 1 into 2 into 3 into 4. It says 24. So it goes on. N factorial is equal to n into n minus 1 into n minus 2 into n minus 3 and so on. Now, as I explained in my previous lecture, we are not doing a mathematics class. We are just doing a physics lecture, and our topic is Basic Maths Section 2 Binomial Theorem. Stating that 1 plus x to the power n, 1 plus nx plus n into n minus 1 upon 2 factorial, n into n minus 1 into n minus 2 upon 2 factorial, and the series goes on. To solve this complete equation is a mathematical process. We are not dealing with mathematics. What we are dealing here is just basic physics, basic maths, which we will need in our MBBS entrance exams. So, if x is very less than 1, if x is very less than 1, then 1 plus x to the power n is equal to 1 plus nx. This is very important regarding our mbbs entrance exams. Very important. If x is very less than 1, then 1 plus x to the power whole to the power n is equal to 1 plus nx. Now we will see the same binomial equation in subtraction form. Here will be just 1 minus x to the power n. It will change 1 minus nx it will change 1 minus nx plus n into n minus 1 upon 2 factorial minus n into n minus 1 minus 2 upon 3 factorial, then again plus, again minus, plus minus plus minus. The sequence goes on minus plus minus plus minus plus 2 factorial 3 factorial. Now again, if x is very less than 1, then 1 minus x to the power n is equal to 1 minus nx. This equation is also very important for our mbbs entrance exam. Now let's see how to use this equation by seeing an example of gravitation. Question is, acceleration due to gravity at height h is g dash is equal to g capital R square upon R plus h whole square, where R is radius of Earth, h is height from the Earth surface. Prove that now we will use the binomial theorem to prove an expression g dash is equal to g 1 minus 2h upon r if h is very less than r. Let's see the question once again. Acceleration due to gravity at height h is g dash equal to g capital R square upon R plus h whole square, where capital R is radius of Earth, h is height from the Earth's surface, and we have to prove that g dash is equal to g 1 minus 2h upon R if h is very less than R. We will use binomial theorem to prove this expression. Our given equation was g dash is equal to g capital R square upon R plus h whole square. Given h is very less than R. Now g dash is equal to g capital R square. Taking R common from this expression, R 1 plus h upon R whole square. Taking R common from this, 1 plus h upon R is equal to g capital R square upon capital R square 1 plus h upon R square. As I took common R common from this expression, then 1 plus h upon R into R, here whole square. Now I am squaring this R, and again this is expression is squared. R square cancelled out. G upon 1 plus h upon R whole square is equal to g 1 plus h upon R whole to the power minus 2. So now we have the equation as g dash is equal to g 1 plus h upon R whole to the power minus 2. We know, let this be equation 1. Equation 1. Now we know that h is very less than R. According to inequalities, we'll see how h upon R is less than 1. According to inequalities, multiplying both sides by 1 upon R is equal to h upon R is very less than 1. Let this be equation 2. This is equation 1 and this is equation 2. Now according to binomial theorem, 1 minus x to the power n is equal to 1 minus nx if x is very less than 1. As we can see here, this is equation 1. H upon R very less than 1 is equation 2. comparing both equations with binomial theorem, G dash is equal to G 1 plus H upon R into minus 2. No matter even if it is 1 minus R or 1 plus X to the power N is equal to 1 plus Nx, matter is same. Both have the same condition that X should be very less than 1. Then 1 minus X to the power N is equal to 1 minus Nx, and 1 plus X to the power N is equal to 1 plus Nx. So 1 plus H upon R into minus 2. Minus 2 is the power. Therefore, G dash is equal to G 1 minus 2H upon R. Proved. So this is the use of binomial theorem. We can use binomial theorem even to expand an expression. Expand an expression to find the square root of some numbers. But we will not use binomial theorem to find the square root of numbers. We will use binomial theorem only for this purpose. Let us revise once. According to binomial theorem, 1 plus x to the power n is equal to 1 plus nx, and 1 minus x to the power n is equal to 1 minus nx for both if x is very less than 1. Only this much is required for MBBS entrance exam. Nothing more than this in binomial theorem. Thank you.